Most of us were taught that math was about getting to the right answer as fast as possible. But today I want to show you why math is actually about strategy, and we're going to use these minifigs to prove it. So here's the challenge. What's the absolute maximum number of minifigs that I can click on top of this base plate? Before I snap them all in, I'm going to challenge you to pause and look at the grid yourself. Drop your guess in the comments. Are you a grid counter? Are you an engineer? Or are you a rogue who likes to think differently? A lot of us look at the studs, those little bumps, and think, okay, total studs divided by 2 per minifigure. That's a great starting point. That's really another word for finding the area. But math in the real world and what we're having kids do today in classrooms is more than that. It's about understanding constraints, understanding more than just simple computation. Notice what happens when I put them side by side. The arms get in the way. Suddenly, my area just changed. It's even more confusing when I give them something to hold. Or maybe looking at their big hair or hat they're wearing. The math isn't really changing, but the conditions are. And what if I think about, maybe I don't need to use both feet. Like here, I'm only using 1 foot. Maybe they only need 1 stud per person. Now here's where the math gets really cool, because this one base plate and these minifigures can be helpful for students at all ages, all the way from kindergarten up to upper level algebra. At each grade level, we're focusing on different strategies. In kindergarten and first grade, I could even be talking about different attributes. Which different minifigs would make sense for me to actually put together? Do I want to choose ones with a bigger hat? Or do I want to choose ones that are holding things with their hands? Or are ones without all of those extra features going to be better? In kindergarten and first grade, we can also think about a 1-to-1 correspondence. 1, 2, 3, 4, 5, 6. Really just counting all. Maybe I then move into skip counting and saying, hey, I've got 6 here. How many more can I put into here? And then in 3rd and 4th grade, maybe I take this out and begin to think about arrays and think about, okay, how many rows of 2? How many rows of 4? How many different rows and attributes can I have? By the time I get to middle school, I might be thinking about proportional reasoning and thinking about, well, if I can fit 3 on this row, I could fit 3 more here, 3 more here, 3 more here, and I can multiply a proportion to see, okay, how much can I fit in each grid? Which again actually relates back to skip counting like we talked about earlier. I can think about raising their hands up. Maybe that'll be helpful. See if I can fit more. Maybe 1 hand up, 1 hand down. If I do fit them, he's kind of in there, and I can kind of see how I fit in there. Maybe I can do 1 more hand up and 1 more hand down. Oh, and he falls down. Maybe that's too tight. Or maybe I could think about spinning some. Oh, he got knocked out. And that's what we call productive struggle. Let's see how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I was able to fit 19 minifigures on this 6x6 base plate. So now to take it a step further, in middle school or in algebra, I might begin to think about, well, if I can fit that many on that size base plate, how about this size base plate? Or how about this size base plate? Math doesn't have to be a lecture. It can be a playground where we explore and identify new challenges. The next time your child's building with Legos, ask them a question like this and see how their mind thinks.